Okay, today we discuss about the second order derivatives in differentiability. All are 5 more questions only. So these are also short questions, right? And here first I'll explain the concept. So how to differentiate and how to find second order derivative with one example. After that we'll discuss that short questions, right? So generally this is the given curve y equal to f of x. If we differentiate y equal to f of x with respect to x on both sides, then derivative of y with respect to x can be written as dy by dx. And this is f of x, na? Derivative of f of x is f dash of x. So this is called first order derivative. But we want second order derivative. For second order derivative, again we have to differentiate with respect to x. Okay. Now write here again differentiated with respect to x on both sides. Then this can be written as d by dx of dy by dx. And here also d by dx of this is f dash of x. So d by dx of dy by dx can be written as d square y by dx square. And here it is f double dash of x. So this is called second order derivative. Suppose if you want third order derivative, once again you have to differentiate on both sides with respect to x. Now see this example. Suppose that y equal to a into e power 2x plus b into e power 3x. Here a and b are two arbitrary constants. Clear? Now this is the first question. Now differentiating with respect to x on both sides. Otherwise just simply write differentiating with respect to x. So it is dy by dx, right? And a into, so now that is the form of d by dx of e power ax. What is the value of this one? A into e power ax. Here a is equal to 2. So 2 into e power 2x. And coming to second one, 3 into e power 3x. So this can be written as 2a e power 2x, 3b e power 3x. So this is called first order derivative. If we want second order derivative, again we have to differentiate with respect to x. So just write here again differentiating with respect to x. So this is d square y by dx square. Means if we differentiate dy by dx, again with respect to x we get second order derivative d square y by dx square. And coming to this 2a constant. And what's the derivative of e power 2x? That can be written as 2 into e power 2x. Again 3b is constant. Then derivative of e power 3x is 3 into e power 3x. Like d by dx of e power ax formula. Okay. Now how much it is? 4a e power 2x. Then 9b e power 3x. This is the answer. That is the required second order derivative of the given equation or given function. Okay. And I'll give one more example. That is example number 2. Suppose y equal to sin square x is given. First we find dy by dx, after that we find that d square y by dx square, right? Now how to write this one? Sin square x can be written as sin x whole square. Now differentiating with respect to x. So it is dy by dx. This is the form of d by dx of x power n. So what is the derivative of x power n? Standard formula n into x power n minus 1, where n equal to 2. X means sin x whole power 2 minus 1. If it is not x, means other than x, again we have to differentiate with respect to x. So if we want, just write here d by dx of sin x, right? And this is 2 into sin x, and derivative of sin x is cos x. So 2 sin x cos x can be written as sin 2x. So this is first order derivative dy by dx. Now again differentiating with respect to x. Then we get second order derivative d square y by dx square. So how to write it? D square y by dx square. And this is the form of d by dx of sin ax. So d by dx of sin ax can be written as a into cos ax, where a equal to 2. So that is the second order derivative. Okay, now this is the first question. So what's the given value? Given that y equal to 3 into e power 2x plus 2 into e power 3x, right? Now differentiating with respect to x. So it is dy by dx, and d by dx of e power ax equal to a into e power ax. This is the formula. So 3 constant, and the derivative of e power 2x is 2 into e power 2x. Why? Because a is equal to 2, and second one 2 constant, and e power ax where a equal to 3. So 3 into e power 3x. So it is 6 into e power 2x, again 6 into e power 3x. So this is dy by dx. But we want second order derivative d square y by dx square, right? So again differentiating with respect to x. So this can be written as d square y by dx square. 6 into, what is the derivative of e power 2x? 2 into e power 2x. And again 6 is constant. E power 3x derivative is 3 into e power 3x. Means again use same formula. Now 6 to get 12 e power 2x. And it is 18 e power 3x. Right? Now what about LHS value? D square y by dx square minus 5 into dy by dx plus 6y. So that equal to d square y by dx square means this is the value 12 e power 2x. So 18 e power 3x. Then minus 5 into dy by dx. So now this is the value, na? 6 into e power 2x. Again 6 into e power 3x. Then plus, what is that? 6y. So 6 into y means given value. What is that? 3 into e power 2x plus 2 into e power 3x. So this is the value. Okay. Now I am writing here. And now how to write this one? So first two terms are same. What is that? 12 into e power 2x. This one 18 into e power 3x. It's over. And coming to this 5 into 6, 30. So minus 30 e power 2x. Again minus 30 e power 3x. Then 6 into 3, 18. Okay. Then e power 2x. Again 6 into 2, 12 e power 3x. Now see that e power 2x term. So 12 plus 18, that is 30. 30 into e power 2x. And 18 plus 12, again 30. So 30 into e power 3x, right? So these two terms, minus 30 e power 2x, minus 30 e power 3x. Now this one, and this one gets cancelled, then answer is 0. So that is equal to, what is that? RHS. Okay, now question number 2. So given function is y equal to sin inverse x. So here also we find first order derivative dy by dx, and again we will find second order derivative d square y by dx square. Okay. So first we differentiate with respect to x, na? Then it is dy by dx. Now derivative of sin inverse x is 1 by root of 1 minus x square. If you want, just write here d by dx of sin inverse x equal to 1 by root of 1 minus x square. After this, do one thing. Actually, it is in denominator, na? So write this denominator value this side. Then how to write that? Square root of 1 minus x square dy by dx equal to 1. And now we want second order derivative d square y by dx square. So again differentiating with respect to x. So UV method. What is that formula? D by dx of UV. What is that? U dv by dx plus v du by dx means u into v dash plus v into u dash. Okay. Now u means root of 1 minus x square. Then derivative of dy by dx with respect to x, d square y by dx square. So u into dv by dx plus v. V means what is that? dy by dx. And the derivative of root of 1 minus x square. So generally d by dx of root x means 1 by 2 root x, right? So by using same formula, this can be written as 1 by 2 into root of 1 minus x square. But it is not x, na? So again we have to differentiate that under square root value. What is that? 1 minus x square. And the derivative of constant is equal to 0. Now it is same, but don't change this value. 1 minus x square into d square y by dx square. And here dy by dx. Then 1 by 2 into root of 1 minus x square. And derivative of constant 0. Then minus 2x equal to 0. So again do one thing. Now take LCM directly. So what is that LCM? Square root of 1 minus x square. And this one, product of these two, na? So root of 1 minus x square whole square. For LCM just I am taking only this term. Why? Because 2 gets cancelled, it is not required. Then d square y by dx square plus dy by dx into, it is 1 by 2, that is minus 2x, then equal to 0. So this two gets cancelled. And in next step, write this denominator value that side. And here this square root cancelled. What is the remaining value? So 1 minus x square into d square y by dx square. Now plus into minus, minus. Then remaining value is x into dy by dx and it is equal to 0. Why? Because 0 into root of 1 minus x square equal to 0. So for same question, I will give second method also. Okay, what is the given value? Y equal to sin inverse x, right? Now differentiating with respect to x, na? So it is dy by dx. And derivative of sin inverse x is 1 by root of 1 minus x square. So if you want, just write here d by dx of sin inverse x equal to 1 by root of 1 minus x square. What we did in previous method, after this, so we wrote this term in left hand side, then it went to this numerator. After that we used that UV method. But here it is not required. Now what I am doing, so directly I am going to differentiate again. Okay, so again differentiating with respect to x. So this is d square y by dx square, and that side d by dx of. So actually in denominator it is 1 minus x square power 1 by 2. If you write in numerator we get minus 1 by 2, right? Why? Because root of x can be written as x power 1 by 2. Now this is the form of d by dx of x power n. So what is the formula of d by dx of x power n? N into x power n minus 1. So that is n equal to minus 1 by 2. X means 1 minus x square. N minus 1. Minus 1 by 2 minus 1. And into d by dx of, what is that? 1 minus x square. Now how to write this one? So minus 1 by 2, 1 minus x square whole power minus 3 by 2. Na? And here it is 0 minus 2x, right? So minus 1 by 2. So 1 minus x square whole power minus 3 by 2 into minus 2x. Now this two gets cancelled. And again minus into minus equal to plus. Then what is the remaining value? So d square y by dx square. Okay. and here 1 minus x square, actually it is power minus 3 by 2. So that can be written as minus 1 and again 1 minus x square whole power minus 1 by 2. Right? Minus 1 by 2 is minus 2 minus 1 minus 3 by 2. Clear? Now write both the values in denominator. And other than that, what is the value here? X. So write here into x. Now same value can be written as x by 1 minus x square. I mean this term. And this can be written as root of 1 minus x square. Why? Because 1 minus x square whole power 1 by 2. Na? Now write this 1 minus x square this side. Then how to write that value? So 1 minus x square into d square y by dx square, right? So here x into 1 by root of 1 minus x square. So what is the value of 1 by root of 1 minus x square? So that can be written as dy by dx. So here 1 minus x square, then d square y by dx square, and x into dy by dx. And finally write x dy by dx this side. Then how to write it? 1 minus x square into d square y by dx square minus x into dy by dx equal to 0. So this is the answer. So in these two methods, which is easiest method for you, you can use that method only. Now this is third question. If y equal to cos inverse x, find d square y by dx square in terms of y alone. Means the required value is in terms of y only. So what is the given function? Y equal to cos inverse x. So from this we get y equal to cos inverse x. Okay, now question number 3. If y equal to cos inverse x, find d square y by dx square in terms of y alone. Okay, now what is the given function here? So y equal to cos inverse x. From this we get x equal to cos y. Right? After that, how to write this one? So just differentiate with respect to x only. So derivative of x with respect to x 1. Derivative of cos x minus sin x. So same formula, minus sin y, but it is not x. Na? So again we differentiate the variable y with respect to x. That is dy by dx. Now write dy by dx value. How much it is? 1 by minus sin y. So minus 1 by sin can be written as cosecant y. But we want second order derivative. Na? So again differentiating with respect to x. Okay. So dy by dx derivative d square y by dx square. I am telling with respect to x. And here derivative of cosecant x is minus cosecant x into cot x. But where y equal to x, right? Means x equal to y. Got it? And it is not x. Then again we have to differentiate y with respect to x. Then how much we get? Dy by dx. Now minus into minus plus. Then how much it is? Cosecant y into cot y. And again substitute dy by dx value. What is the value of dy by dx? Minus cosecant y. Clear? Now plus into minus minus. So it is cosecant square y cosecant into cosecant into cot y. So now total function means required value is in terms of y only. Na? That is the meaning of this question. Okay, now this is fourth question. y2 means second order derivative d square y by dx square. y1 means first order derivative dy by dx. Okay. Now what is the given value here? Given that y equal to 3 into cos of log x, then 4 into sin of log x. So according to the required value, we'll find dy by dx and d square y by dx square, right? And now first differentiating with respect to x. Then it is dy by dx. 3 into derivative of cos is minus sine of log x. But it is not x. So again you have to differentiate log x with respect to x. So what is the derivative of log x? 1 by x. So right here into 1 by x plus 4 into. So derivative of sine is cos. So cos of log x. Again 1 by x. So here x is in denominator, here also x is in denominator. Na? Now take LCM. So what is that? LCM is x, right? After that minus 3 into sine of log x, 4 into cos of log x. Now write this denominator x this side. Then how to write this? X into dy by dx. So minus 3 sine of log x, 4 cos of log x, right? So it is only first order derivative, but actually in this required value second order derivative is also there. So that again we have to differentiate with respect to x. So again differentiating with respect to x. Okay. Now for this uv method, so what is the formula of uv? d by dx of uv. So u into dv by dx plus v into du by dx, right? And now x into derivative of dy by dx with respect to x is d square y by dx square plus dy by dx. Okay, and derivative of x is 1. So how to write this? Minus 3. Derivative of sine is cos. So cos of log x. Again derivative of log x is 1 by x. And coming to this, 4 into derivative of cos is minus sine, then minus sine of log x, then again 1 by x. Now again take LCM. So that is x, right? And in this minus is common, right? What's the remaining? So 3 into cos of log x, right? And minus is common, then again it is also plus 4 into sine of log x. Clear? In next step, just write x this side. So x into x, I am writing direct step. Okay, x square d square y by dx square. Again x into dy by dx, right? Equal to minus. So this whole bracket value is equal to given function y. So just write here y. Clear? And x square, it is y2. So plus x y1. If you write minus y in left hand side, we get plus y equal to 0. That is the answer. Okay, now this is fifth question. So what is the given value? Y equal to a into e power mx plus b into e power nx. In this also we find the dy by dx, then d square y by dx square. So first differentiating with respect to x, right? And it is dy by dx equal to, now what is the formula of d by dx of e power ax? A into e power ax and a into m into e power mx. Why? Because a is equal to m plus b into, this can be written as m into e power nx. So am e power mx, bn e power nx. So this is first order derivative dy by dx. Now again we find second order derivative. So for that again differentiating with respect to x, right? So how to write this one? It is d square y by dx square. So am, again is same formula. So e power mx derivative is m into e power mx. And here it is bn, n into e power nx. So am square e power mx, bn square e power nx. So that is the second order derivative d square y by dx square. Now what is that left hand side value? So d square y by dx square minus of m plus n into dy by dx plus mn into y. Clear? And now d square y by dx square means this is the value am square e power mx, bn square e power nx, right? Minus of m plus n into dy by dx. What is that? Am into e power mx, bn into e power nx, then plus mn into y. What is y? A into e power mx, b into e power nx, right? And now first two terms are same. I am writing here. So what is the first term? Am square e power mx. Second one is bn square e power nx, right? Now see, m into am square e power mx before minus, na? So that can be written as minus am square e power mx. Again m into bn, that can be written as bmn before minus. So minus bmn e power nx. Now multiply this term and this term. This term is bracket value. Okay, what is the first one? N into am. So amn. So again write here minus amn e power mx. So now minus n into bn is bn square, na? So bn square into e power nx. Now this is plus, so mn into a, that is amn e power mx, and last one is bmn e power nx. Now see, this is positive value, this is negative value, both are gets cancelled, right? And this plus, this minus gets cancelled. So this is minus bmn plus bmn minus amn plus amn equal to 0. So that equal to RHS. Now sixth question. It's a very simple question. What is the given value here? Y equal to 500 e power 7x plus 600 into e power minus 7x. We find the second order derivative. For that first we find first order derivative dy by dx, right? So differentiating with respect to x. So it is dy by dx. So 500 into, which form it is? D by dx of e power ax formula. So a into e power ax. Now what is the value of a? 7. 7 into e power 7x. And 600 minus 7 e power minus 7x, right? Now again differentiating with respect to x. Don't multiply these two. Now d square y by dx square, right? 500 7. Again derivative of e power 7x is 7 into e power 7x. And coming to this one, 600 minus 7, then minus 7 into e power minus 7x. So 7 into 7 49, 500 into 49 e power 7x. And here plus 600 minus 7 into minus 7, again plus 49 e power minus 7x. Now 49 is the common value. So 500 e power 7x, 600 e power minus 7x. So this whole bracket value is equal to y. Then how to write this? 49y. So that is the final answer. Okay. Now this is 7th question. So it's also a very simple question, but here we find first order and second order derivatives, right? So given that e power y into x plus 1 equal to 1. Now differentiating with respect to x, and uv method. What is that? D by dx of uv equal to u dv by dx plus v du by dx, right? Now we apply this formula. Now this is u, this is v. So u into, so d by dx of x plus 1. Actually it is not required, but I am writing one step extra here. Plus v. V means x plus 1. And d by dx of e power y. Right hand side d by dx of 1. Now e power y into derivative of x is 1, derivative of 1 is 0. And coming to this x plus 1. Now derivative of e power x. What is the d by dx of e power x? It is e power x, right? So for e power y, first we use same formula, but it is not x, na? So again differentiate that, then we get dy by dx. So, and derivative of constant is 0. So in this e power y is the common value. So here it is 1, that is x plus 1 into dy by dx, then equal to 0. But e power y is not equal to 0. If e power y is not equal to 0, then remaining bracket value is there, na? That is 1 plus x plus 1 into dy by dx. It is equal to 0. Right? And from this we get x plus 1 into dy by dx equal to minus 1. Now what is the value of dy by dx? Minus 1 by x plus 1. Now this is first value. After this, actually we want second order derivative d square y by dx square, right? Now again differentiating with respect to x. Again differentiating with respect to x. So derivative of dy by dx with respect to x is d square y by dx square, right? And that one, so d by dx of minus 1 by x plus 1. So minus d by dx of x plus 1 whole power minus 1, right? Now minus, which form it is, d by dx of x power n. So n into x power n minus 1. And but it is not x, na? So again differentiate the bracket value. So minus into minus plus, it is x plus 1 whole power minus 2. So d by dx of x is 1, d by dx of 1 is 0. So if you write minus value in denominator, we get 1 by x plus 1 whole square, na? So this is d square y by dx square. What is the actual value of dy by dx? This is minus 1 by x plus 1. Now SOB, squaring on both sides. Then how to write it? Minus 1 by x plus 1 whole square, right? So minus 2 whole square is plus. So 1 by x plus 1 whole square. Now what is that final conclusion? D square y by dx square equal to dy by dx whole power 2. So this is the required value. Clear? D square y by dx square equal to dy by dx whole square. This is the last question. See what is the given value? Okay, now this is last one. So what is the given value here? Y equal to tan inverse x whole square, right? First step, what is that? Differentiating with respect to x. So it is dy by dx. So this is dy by dx of tan inverse x whole power 2. That is dy by dx of x power n formula, na? N into x power n minus 1. But it is not x. So again differentiate that value. That is d by dx of tan inverse x. So here it is how much? 2 tan inverse x. Right? And d by dx of tan inverse x is 1 by 1 plus x square. So if you want, just write here d by dx of tan inverse x. So 1 by 1 plus x square. And here d by dx of what is that? X power n. N into x power n minus 1. Now do one thing. Denominator value is there, na? Write this side. Then we get 1 plus x square into dy by dx. And here it is 2 into tan inverse x. But we want second order derivative, d square y by dx square, right? So again differentiating with respect to x. Now UV method. What is that formula? D by dx of UV. So u dv by dx plus v du by dx. Clear? So u means 1 plus x square. If you differentiate dy by dx again with respect to x, we get second order derivative d square y by dx square plus v. What is v? dy by dx. Na? Now derivative of 1 plus x square. So derivative of 1 is 0, derivative of x square is 2x. And coming to right hand side, 2 into derivative of tan inverse x, what is that? 1 by 1 plus x square. Clear? Again write 1 plus x square in left hand side. Then how to write this value? I am writing here. Okay. So 1 plus x square into this whole value. What is that? 1 plus x square into d square y by dx square. And 0 plus 2x means 2x, right? Then dy by dx equal to, that side only 2. Now multiply these two terms. So 1 plus x square into 1 plus x square. So 1 plus x square whole square. Na? And d square y by dx square can be written as y2. Now second term 2x into 1 plus x square. And it is y1 equal to 2. That is the required value.